through a machine learning project which I am doing as a part of completing my AI project management course on Coursera. So basically, what we're going to do is we are going to go through, um, different stages of product management, building up a product management use case for our machine learning project, which includes starting with opportunity evaluation, and then once opportunity is evaluated, we go through business understanding, defining our outcomes and outputs. Then we will go through the validation plan, ML system design, and also list some potential risks in production with this project. So what is the problem we are trying to solve? The problem we are trying to solve is we want to predict when a compressor, and I'm going to use the word asset uh, instead of compressor, when this asset needs maintenance. And the main benefit of this project is that we want to lower the unscheduled downtime, maintenance downtime for this particular asset. And how is the maintenance done today? The current solution is time-based maintenance. So every month, or every few weeks, uh, based on the time schedule, an asset is brought down and maintained, and then put back into service. But we want to utilize machine learning to see if we can move from time-based maintenance to need-based maintenance. And to solve this problem, what we're going to do is we're going to install three different sensors on the equipment. One is the vibration sensor, other is amperage draw sensor, and third is the temperature sensor. And we're going to use this data or these features to train a machine learning model, which will then give us idea on when the asset would need maintenance. So let's start with the business understanding of the problem, right? So what is the problem? Who are the target users? The target user for this machine learning system would be asset maintenance crew. And as I said, the problem is we want to know when the maintenance of the asset is needed. And we need to know based on the need, not based on the time. Why it matters? Obviously, if the asset is going down unscheduled, there is a loss in production, which has direct impact on the production and available product for sale. So it is linked to the dollar amount, and we talked about this. The current state is that the crew is using time-based maintenance schedules to service the equipment, the asset. So how do we define this project in terms of success? What success looks like. Um, so what is the expected impact of this project? It will reduce the asset downtime, unscheduled downtime, to be more accurate. And so there are two types of metrics, right? One is the outcome-based metrics, which are business related metrics, and the other one is the output related metrics, which is more model related metrics. So for our outcome slash business related metrics, we want to reduce the asset downtime. And for our output model based metrics, the model is we will see in few minutes what the model is. But the output, it's kind of a clustering algorithm, and the output for that would be dB index, a lowering of dB index. All right, so what are the constraints? Are there any constraints on this system? So one of the requirements of this project is that the prediction must be delivered 24 hours in advance of needed maintenance. So before we think that maintenance is needed, the system should be able to give us an advance notice of 24 hours. And what are the data factors? What are the factors we're gonna collect? We talked about the three sensors: temperature, vibration, and amperage draw. we are going to use this data to train the model. So these sensors, so where is the data going to come from? The sources of data is the IoT sensors, which will be calibrated and installed on the equipment. And what we have also kind of defined the granularity of the data we need. So we will be pinging data every 5 seconds, and from all these sensors, and then basically capturing it in a CSV file, which will then be uploaded on the cloud to train Azure multivariate anomaly detection model. Multivariate means more than one variable. So we talked about 3 variables here: temperature, vibration, amperage draw. That is what multivariate. If I say univariate, it is just one variable. So this machine learning model, we will tap into that machine learning model through an API of Azure. And what we're going to do is we will basically start collecting the data from these sensors every 5 seconds, and we will collect this data for 30 days. And one thing we will make sure before we collect the data is that we service the asset right before we start collecting the data. And what we want, why are we doing this? What we want here is that we want this data to represent normal, or what is the good data to train the machine learning model. So once machine learning model trains on this data, and this data is the good data, it knows what normal looks like. And if anything outside of normal happens later on, it will be able to identify that. Another aspect we have to look into is machine learning system design. So there are basically 3 things in machine learning system design. Is it going to be a cloud-based system, or is it going to be on an edge device? For our use case, we determined that latency is not a big issue. If we are able to get predictions in 30 seconds, it's good enough. We don't have to have millisecond latency. So edge is really not, although it can be done, we are okay with deploying our model in the cloud. Will the model use online or offline retraining method? So in our case, we decided that this ML system will use an offline learning. We don't need this model to be retrained frequently, since the definition of good or the normal behavior does not change that often. So we may not need to retrain this model that frequently. So we're going to use offline learning. We might retrain the model every month, or something like that. And lastly, do we need batch prediction, or do we need an online prediction? In our case, it makes sense to have online prediction, because we need to know as soon as possible when the data from these sensors start behaving abnormally, and we need to know it right away. So we're going to use online prediction as a method of prediction. And what are some of the potential risks as we implement this model in the machine learning model for our use case? I mean, one possible issue I can think of is that our IoT sensors might start working malfunctioning and not sending out the data every 5 seconds. That can cause some issues. If all the 3 sensors are not working, maybe just one is working or 2 are working, the model does not have, in that case, the whole data to do the inferences. So that could be a potential issue, but there are techniques, ways to monitor the sensors as well, by building some basic alarms. So if sensors stop pinging, it can send out an alarm, and somebody can go look at it and fix the issue. So that was my project for the asset, for the equipment using machine learning. Thank you.